Hey everybody, Mr. Covey here, and this is the first of 3 videos dealing with graphing rational functions. Okay, so this should be watched after we do that in-class activity on the block day, and I'm going to go through how to graph a few rational functions here. So these are rational functions because they are a fraction. Okay, the best thing to do with rational functions always is to factor if you can. So in this case, we can only factor the denominator. Difference of 2 squares, it factors to x plus 2, x minus 2. Okay. Our goal is to graph this, but in order to graph it, it really helps if we identify some of these characteristics over here first. So because it's a fraction, remember that if you have a fraction, you cannot have 0 in the denominator. So any number on top divided by 0 is not 0, undefined. Okay, so you can't have 0 in the denominator. So looking at this fraction, if I set my denominator equal to 0, well, that happens when x equals -2 and positive 2. Sorry, positive 2. So when x equals -2 and positive 2, my denominator is 0, so those are not in my domain. And in fact, at those points, what I end up having, because those are not in my domain, is a vertical asymptote. So there's a close connection between these two things. I like to start with the domain. So I'm allowed to plug in as small of numbers as I want, negative infinity. I need to stop at -2. I'm not allowed to plug in -2. I'm going to pick back up at -2 though, because -2 is the only number that I can't plug in. I can plug in things really close to -2, like -2.001. And I can plug in -1.999. I just can't plug in -2 itself. So that's why I got those parentheses there. I can plug in anything between -2 and 2. Can't plug in -2. Or sorry, can't plug in 2, so I put a parenthesis. And then I'll put that together with 2 to infinity. So what this notation is, important notation you need to know, definitely for next year. It just says x cannot equal -2 or 2. That's because at -2 and 2 I have vertical asymptotes. Please remember vertical lines are x equals, so x equals -2 and x equals 2 are 2 vertical asymptotes. If I want to jump over to my graph, I can graph those vertical asymptotes. So at -2, draw them as dotted lines like we always do with asymptotes, and at 2, I have vertical asymptotes. Now to discuss the issue of the horizontal asymptote. So you'll remember from class, what we need to look at is the degree of the numerator. The degree of the numerator compared to the degree of the denominator. So the numerator has degree 0 really, because it doesn't even have an x. The denominator has degree 2. The important thing is that the denominator's degree is more. So we're going to have an asymptote at y equals 0. Okay, so it comes down to comparing the degree of the numerator and the denominator. So y equals 0 is going to be my horizontal asymptote. And the horizontal asymptote directly ties in with end behavior. So something that's good to remember is thinking about vertical asymptotes and domain being connected, and horizontal asymptotes and end behavior being connected. Because if I have y equals 0 as a horizontal asymptote, well, that just means as I go off the graph to the right, my y's are going to go to 0. And as I go off the graph to the left, my y's are going to go to 0. And that notation is similar to what we use in polynomials. Exactly the same. So that notation should be familiar. Couple other things that we've done for a lot of different functions. Zeros are a fancy name for x-intercepts. If you want to find an x-intercept, remember you make y 0. Okay, so coming back up here, I know we got a lot of stuff going on here. Let's do it over here. If I'm going to see when does write that nicer. When does 1 divided by x squared minus 4 equals 0? That can't happen. 1 divided by something can't be 0. And that means there's no y-intercept. excuse me, no x-intercept, no zeros. Never crosses the x-axis. Kind of makes sense based on the fact that we have y equals 0 as a horizontal asymptote, although that won't always be the case. To find y-intercepts, we make x 0. Easy enough. 1 divided by 0 squared minus 4. Well, that's just negative 1/4. So my y-intercept is 0, negative 1/4. Please note that the y-intercept is like an actual point on the graph. So I should jump over to my graph and plot 0, negative 1/4. It's a little off, but like up there. But that's actually a point on my graph that I know. Last thing I have to do is see how the graph's kind of chopped up into 6 different sections? I have to decide like what sections the graph's actually in. So because it's a function, it couldn't be in like this section and this section at the same time, because then it wouldn't be a function. So it's either in like the top or the bottom, and the top or the bottom, and the top or the bottom. So I kind of have 3 decisions I have to make here. If you look at that y-intercept I just plotted, that blue point, that tells me that for that chunk of the graph, I'm in the bottom. Okay, so I don't know exactly what my function looks like, but I know it goes through that point, and it's going to be below the y-intercept. So I'm just going to sketch something like that. I know it's going to get close to those vertical asymptotes, because that's what vertical asymptotes are. So it's going to look something like that. Over here, I just need to plug in a point. And over here, I just need to plug in a point. So go ahead and take a second to plug in 5 and negative 5 and see if you get out positive or negative numbers. So go ahead and do that real quick. Plug in 5, you should get 1/21st, super small number. When you plugged in negative 5, you should have also got 1/21st. What that tells me is that over here, my graph looks like this. It goes through that point. It's going to get real close to that horizontal asymptote, and as it goes over here, it's going to get real close to that vertical asymptote. Same thing over here. I did it! I graphed my rational function. Okay? So, I graphed it, and there are all my characteristics over here. Okay? So all of these are going to kind of follow a similar process. There are some trickier ones. Feel free to jot down any additional notes, kind of like that summary we did in class on the block day about like how do you find the y-intercept, how do you find the horizontal asymptote. There's all those different processes. When you're good there, jump ahead to the next page. I'm going to do one more example with you, and then I'm going to kind of have you do the last one and check your answer. Okay? So again, factor. Factoring is definitely the best first step. So I'm going to take a second real quick here and factor this. Oh no, I'm going to factor wrong. Sad. Not good. All right, there we go. Cool. For the bottom, don't forget the GCF. Makes your life easier. So I'm going to write it over here. Take out the 4. Boop, boop, x squared plus x minus 2. So it's going to have a 4, and then it's going to be x plus 2x minus 1. Okay, so this is my factored form. Really, for everything except for the horizontal asymptote and end behavior stuff, looking at the factored form is best. Okay, so we'll come back to those. But now that I got it in factored form, what's going to make my denominator 0? Negative 2 and positive 1. So negative 2 and positive 1 are going to be my vertical asymptotes. So I'm going to toss those down. Negative 2. Cool. Remember that vertical asymptotes are directly tied in with domain. So those are the points that I cannot have. The way to write that in interval notation is I can go up to negative 2, but I can't hit negative 2. I can go from negative 2, not hitting it, to 1, cannot hit 1. That's why I'm using these parentheses, and then I'm allowed to go from 1 to infinity. Those are all parentheses. Cool. Next thing, horizontal asymptote. In this case, I have a slightly different situation. The degree of the numerator and denominator is both 2. They're both squared. So then I got to look at the ratio of the coefficients. Okay, what I'm looking at is the ratio of the coefficients. The top coefficient, well, there isn't one. It's because there's a little 1 there. The bottom one's coefficient, the bottom polynomials, is 4. So then my asymptote is 1 over 4. That is my horizontal asymptote. So y equals 1/4. It's just a horizontal line, but it's just a little bit above 1, or sorry, a little bit above 0. Less than 1, it's just 1/4. So it's somewhere like right there. Okay. So then that tells me my end behavior. As x goes to infinity, sad infinity sign, my y is going to go to 1/4. And as my x goes to negative infinity, my y is going to go to 1/4 too. Okay. Sorry, it's a little sloppy there. X-intercept, y-intercept. So I'm going to plug in 0 for y. Let's be a little careful here. Okay. So a x-intercept, I'm going to make y 0. So please be careful here. If you have a fraction equal to 0, that means the numerator is 0. Okay, so look at my fraction. If the numerator is 0, that's going to happen at -3 and -4. So at x equals -3 and at x equals -4, I'm going to have x-intercepts. I should really write those as points. So -4, 0 and -3, 0 are x-intercepts. Those are actual points on my graph. Okay. If I plug in 0 for x, I get out my y-intercept. So I'm going to plug in 0 for x, I'm going to get -1 1/2, and that's my y-intercept. So my y-intercept's 0, -1.5. So I got my x-intercepts, I got my y-intercept. I am ready to roll. I'm ready to sketch my graph here. I actually know a lot of things about this graph, but so I definitely know, like right here, it looks like this. I don't know what happens over here, so I'm going to plug in some x value. So go ahead and why don't you plug in 5 for x. And then over here, it's still a little unclear what's going on because I have these two x-intercepts. So why don't you plug in another point or two? Why don't you plug in -5 here and 5 here? So go ahead and plug in -5 and 5. And to clarify, because we're not using our calculator, I just need to get kind of like a rough estimate of where it is. In other words, really whether it's positive or negative is the important information. So 5 is a slightly positive number, a little bit above our asymptote. -5. Positive number is slightly below our asymptote. Based on that, I know my graph goes up over here like that, and over there. And then over here, it looks kind of weird that I have these two here. It actually ends up going like that up there. Why does it curve up instead of down? You might plug in one extra point to see that. So maybe if you plugged in -2.5, you could see that it actually shoots up and shoots down. So plugging in more points will help you get that shape there. The important thing is the characteristics, because they definitely give you the overall look at what the graph looks like. Also, a lot of the graphs switch between up, down, up. Not always, but a lot of them do. What I'd like you to do now is pause, take, I don't know, however long it takes you to try this last problem, and then unpause and check if you got the answer right. Okay, so this is what I ended up getting. Just to go through my process real quick here, I factored the numerator and denominator, found my vertical asymptotes in my domain. There was no horizontal asymptote because the numerator of the degree of the numerator was greater than the degree of the denominator. I plotted my zeros, my x-intercepts, and then I kind of sketched this graph. All right, so you can go ahead and move on to the practice problems. There's an answer key up on Schoology, and we'll keep working on this. Thanks.